philosophy and my attitude right now towards training is that I don't say no to any training that is coming across, whether it's RabbitMQ or Message Queue or Apache Web Server. I do it all and take it all and do it as my passion. I also started a company of my own where slowly I'm kind of moving towards taking more and more assignments and challenges. Quickly, last but not the least, I keep taking a lot of big webinars also for all these huge multinational organizations like Cognizant and TCS and Infosys and Wipros and HPs of the world. And participants would be anywhere between 700 to 1,000 participants from all across the world, and these organizations would just ask me to pick up one topic and present it to these students who would just get an idea about about just a whiff of what the technology is all about. So yeah, that's what is. We can apply for the job. Then, oh yes, Tanmay, you can definitely. I'm a 1 or 2 man show right now. But you can definitely do that. Very soon, see, Bangalore is the hub of all this, right? So you can definitely. So yeah, session has started. Santosh Kumar, hopefully you're able to hear us all, hear me and make sense of what I'm saying. Excellent. So I'm just going to come out of this presentation back to my, just 1 second, give me 1 second, back to my cheat sheet. So those of you who are from my session, you would know that this is how I go about my session. Shobhit Shrivastava, this is what I'm exactly telling right now. This is my cheat sheet where topics for today is listed down. So I keep giving the topics, I keep giving the presentation, keep coming back here and keep kind of marking it as done. So this is what I've done. I've given my introduction right now and I've marked it as done, which is great. My cloud storage is crying for something, so I just said the answer to it. Is there any classroom session in Bangalore? Suresh Babu. So okay, so guys, apart from this TOC, towards the end of the session, couple of minutes I'll keep for question and answer session, and also during the presentation at logical point I'll stop and pick up some of the relevant questions. So if you have questions like what Suresh Babu is asking, or anything related to any course or any session, you can wait till I finish the portion, and after that I'll answer the question, and if it's really something that I cannot answer, I'll guide you towards the right channels who can help you out. So the way I've structured this session, guys, is that I'm going to just give you a bit about a brief about big data, tell you about some big data technologies built towards Spark and as a technology, tell you a little bit basics of the Spark, and then slowly dive into machine learning, which is the topic of the presentation, and also I'll try to give you some idea about some of the hands-on and kind of get a feel of it from the perspective of Hadoop as a technology, from the perspective of Spark as a technology, and from the perspective of machine learning as a framework. So that's what the idea I have in my mind. Anyway, a quick introduction to big data. So what is big data? Very quickly, big data is is huge amount of data. Is such a huge amount of data that that is something that you cannot store on your individual single machine. Let me get started with that. Nowadays, let's say a fair scenario. Let's say if you're working on a desktop. The maximum of hard disk that you would have on your desktop would be somewhere around 1 terabyte or 2 terabyte. Data which goes beyond that. Usually when I start my session, people ask me what is the threshold for big data. I say that any decent size computer that you're working on, and on that computer, if you cannot save and process some file which is so huge that you cannot save and process it on your computer, that is where the game begins. So that is what is big data. Now, since there are various characteristics, usually when I take my session, I spend some 2 hours on this. So it's a huge topic. the various characteristics, the volume in terms of volume, in terms of variety, in terms of the speed at which the data comes in. There are some 7 or 8 characteristics over there. But I'm going to basically concentrate on two areas. One is since I said about the volume, I'm going to say that okay, since volume is so huge, storage is a big challenge. And then so you cannot store it on your single machine. You have to move to a multi machine system, a cluster of computers, some more formally called as distributed computing cluster. I'm trying to kind of speak the formal language. So distributed computing cluster, yes, and once you're able to save this data, the other bigger challenge is how to process it. Now the data is saved, now I'm able to open it, but the reason why I have saved this data has been my asset. I want to analyze it. And if I want to analyze it, is there a processing mechanism in place? Is there a technology in place? Is there a framework in place? Yes, the good news is that there are technologies in place, there are frameworks in place, and there are actually solutions in place which actually are directed towards these challenges which big data throws at you, which big data imposes in front of you. Right. So I'm going to give you a bit of idea about those technologies and tell you how these technologies get married to big data, if I can use that term. They get they get married to big data and provide the solution. So yeah, that was the quick introduction to big data. Pity that I don't have much time to spend on this. Usually I'd like to spend 2-3 hours on this. But anyways, challenges with respect to big data, as I said, storage. Ta-da! Storage is a problem. Yes, storage is a problem because the volume is so huge. Right, the volume is so huge. Storage is a problem. You would need a solution like cloud computing. Right, like cloud computing to store this data. And once you store this data, processing is a problem. Right, how would you process this data? Right, these are the two challenges which big data throws in front of you. Right, what is the technology which provides the solution to these two challenges? What is the technology which provides the solution to these two challenges? Hadoop is the technology which provides solution to these two challenges. Right? Hadoop is the technology, and Hadoop has been the technology from last 2-3 years. Everywhere you go, right, at this point of time, people talk about big data and Hadoop. Hadoop is the solution. Big data is an asset, Hadoop is the solution. Right? Big data is an asset, Hadoop is the solution. Right? But there are certain challenges coming over there also, which we are going to talk about, and then slowly build up towards better, faster, more performance efficient frameworks. We are going to move towards that, right? But just to get a whiff of what Hadoop as a technology is. Again, this is something on which I spend close to some 8 hours, 8 to 16 hours. People who are doing my batches know this, but just give you a cursory look at it. Hadoop is an open source framework. It's an open source framework supported by community, free of cost, off the shelf, pre-programmed, pre-tested libraries available to you, which you can use it, and it provides an automated distributed computing environment. Fair enough. Distributed computing is anyway a big challenge. Right? Having a cluster of 50 machines, one machine is going down, one machine is going up, you are coordinating processing between these different machines. It's a big challenge. Anyway, it's a big challenge. Right? So Hadoop provides an automated distributed computing by way of providing this framework, Hadoop framework, which is free of cost. Right? Excellent. Now, the bigger deal is that it provides solution to these two challenges. Right? It provides solution to these two challenges, storage and processing. The challenge of storing big data is provided by something called as HDFS in Hadoop. The challenge of storing big data is provided by Hadoop Distributed File System, or in short HDFS by Hadoop. It's based on some Google white paper called as GFS. Simple, right? And processing, which is the other challenge, is met by something called as MapReduce algorithm, which also has an implementation in Hadoop. Amazing, very good. This is also based on one of the white papers by Google. Very good. Sound backing, great solution, has been working very well. We've had multiple versions of it, 1.x, 2.x, right? In a couple of months time, 3.x is also coming in, right? But in the last, I would say, an year or so, people have started facing problems with that, right? So people have started facing problems with that, and that is where these new age frameworks like Spark, like Tej, right? And all these engines are coming in. That is where these new age engines, processing engines are coming in. I mean, if you are from the Hadoop background, and if you happen to install, let's say, Hive on your system, you would see that Hive will give you a warning. And if you're installing Hive on underlying MapReduce, right, it'll give you a warning saying that MapReduce will soon get phased off. Has anybody seen that? Right? MapReduce is soon going to get phased off. Right? Replace your processing engine for something by something which is more latest, more performance efficient, like Tej or Spark. Right? If you've not seen that, do the installation of Hadoop and do the installation of Hive. Immediately you're going to get this warning. And by the way, it basically, let me just complete this and say that, okay, challenges I've spoken to you about. This I have done. Before I move on, and since I was talking in terms of the installation, my friends, this is a good time to just introduce you to this blog, which all my students, all my participants, they use it. This has all the installation instructions for all the big data technologies. Right? So I suggest you have a look at it. So off late, I have been doing the installation of HDFS high availability, which is, I think, halfway through right now. Very soon I am be doing it for resource manager high availability also. Starting from single node Hadoop installation to Pig, Hive, whatever, you're going to find this in this, even a multi-node cluster on a single machine. I don't have time, otherwise I would have run a multi-node cluster on and run all these softwares, like all the Hadoop ecosystem software, as well as all your Spark and all the machine learning examples as well. But anyways, all this setup is something that this blog is going to tell you. Anyways, so that's a quick detour from what I was presenting to you. Anyways, so available solutions for the above challenges, Hadoop, right? And now while we're talking about Hadoop, let's go ahead and quickly run a Hadoop program as well, right? How does the Hadoop commands look like? Right? They look like this, right? Isn't it? Anybody who's working on Hadoop already would know this, isn't it? Would know this, isn't it? Would know this, right? I'll just delete this this directory called as output directory. By the way, all these commands are also there on my blog. Amazing, very good. Let us run a Hadoop program, which will use MapReduce to run itself. Right. Right, it would use MapReduce. It's a simple word count program which is usually called as hello world of Hadoop. Right, it will run itself. Amazing, it will run, it will get completed, right? It will give you the word count, fine enough, fair enough. But then what about the problems with MapReduce? There are some inherent problems with MapReduce, right? Which people have started realizing, right? If you know something like shuffle and sort in MapReduce, you would know that in the shuffle and sort process, mappers, which may be thousands in your Hadoop cluster, dump the output on the local machine on which the mapper is running. Right? If you look at this job, you would see that one file was input, one map task was instantiated. It ran, it gave the output got dumped on the machine on which the mapper was running, from where the shuffle and sort mechanism picked it up. Right, from where shuffle and sort mechanism picked it up and then passed it on to the reducer. Right, that is the problem. The fact that the output from the mapper is getting dumped on the hard disk. Writing the values on the hard disk is a performance intensive exercise. Right? Writing the values on the hard disk is a performance intensive exercise. People wanted to avoid it. And that is where framework like Spark came into picture. Right? That is where framework like Spark came into picture. I'm just completing the sample run. All right, if you really intend to see what has gone inside that output file, you can go here and say ls and say output. You can get it. Right, and then you can do a cat of it, and you can see the word count. I mean, it's trivial. Should be trivial for you. 1, 2, 3, 4, 5. Kadak. You can get it. Right. Demo for word count is done. Okay, fine. But there is an inherent problem, as I said. The inherent problem over here is that the mappers write to the disk. They run combiners. They run partitioner. It's a performance intensive exercise. It's a performance incentive exercise. Right? In comes a new age framework called as Spark. What Spark does is that it does not write the output in the disk on which your jobs are running. It has renamed this as well, the components as well. Right? Mappers and reducers in Hadoop, as they are called, they are now called as executors. Right? Nodes in MapReduce, they are now called as worker nodes. Right? In Hadoop. All right. So where Hadoop fails to live up the promise, very well we have understood. Hadoop fails the promise in terms of writing the output of the mapper on the machine on which the mapper is running. Right? That is what is the biggest problem. Right? Done. Understood. Very good. Due to the scarcity of time, I'm actually telling all these things to you guys in short. Needless to say, these are the things which I cover in detail when I take my full-time session. Anyway, so this is what it is. Just 1 second, guys. Give me 1 second. Yes, Rohit, I'm going to throw some more light on Spark is a replacement of MapReduce in Hadoop, Rohit. Right? HDFS would remain, and it is still not a replacement officially, Rohit. Right? It is going to come there in some time with the latest version of Hadoop. Right? Private players like Cloudera, for example, have already done that. Hortonworks, for example, have already done that. If you go to the Cloudera website and download Cloudera virtual machine, you will see that instead of MapReduce, you will find Spark over there. Even their exam also expects you to prepare on that, right? But it's not officially there, although it is going to be there. And the see, Hadoop is version Hadoop version 2.7.2 right now, right? Right. I think I've been reading this in the community. I think 3.0 is where Hadoop MapReduce is going to be completely phased off. And then, in fact, right now also you can run. There is an integration between Yarn and Spark. So you can within Spark you can run Yarn jobs, which is MapReduce in 2.x. So yeah, there is an indirect relation, but formally, officially, it has not been done. Right, Rohit. So that was Rohit. In comes Spark. The definition. Let us go ahead and see the definition. Right. This is my cheat sheet, guys. If you at the end of the presentation, if you want a copy of this, you can ask the support team to have a copy of it. They'll be more than happy to supply it back to you. I have prepared all the content right over here only. Not a big fan of creating PPTs. At some point of time they become boring. I believe more in terms of writing here and then typing and then showing you graphics. Wherever needed, I try and go and try and see only the graphics on the PPT, and it makes sense. Anyway, so this is what it is quickly. Apache Spark. What is Apache Spark? Apache Spark is a fast and general purpose clustering computing system. Fast, right? Fast. That is the watchword. Right? Fast, performance efficient. Right? From a lot of people, you would have heard this term real time. Right? Spark is a real time framework, which would give you, given that you would have experience in working RDBMS, you would immediately think Spark is a framework which can be plugged behind an online transaction processing system. right? Which usually uses RDBMS. The question that you should ask yourself over there is Spark a replacement for RDBMS? And the answer that you're going to get is no. Spark is not the replacement for RDBMS because RDBMS is meant for different purpose. RDBMS is meant for working in applications which require high throughput, low latency access. I want to buy my mobile from Flipkart. I want to buy my mobile from Amazon. I want to buy it right now. When we are talking about Spark, when we are talking about Hadoop and its related technologies which provide solution to big data challenges, we are talking about batch analytics. We are talking about business analytics. And whenever we talk about business analytics, whenever we talk about batch analytics, my friends, we can never talk in terms of real time. We can always talk in terms of faster, more performance efficient access. Hadoop and Spark and its related technology have got some real-time access technologies also, like NoSQL, for example. Right? NoSQL is a database like MongoDB, like Edgebase and Cassandra's of the world. They can be plugged behind an online transaction processing system. Fine. Right? They are meant for that purpose, but not majority of the technology in Hadoop ecosystem, Hadoop and Spark. Spark is fast, Spark is efficient, but again it is batch analytics because it cannot be plugged behind an online transaction processing system, my friends. Right? It's a general purpose cluster computing system for business analytics that needs to be done in a batch oriented fashion. I cannot harp enough on that, my friends. Right? I cannot harp enough of that. Right, Martin is saying Spark is actually near real time. I think Martin, from my discussion, from my explanation of last 5 minutes, you would have exactly got what it is, isn't it, Martin? Right? Because I know Martin and all my other friends. I know what are the kind of questions which will come into your minds. I know what is the kind of confusion, what is the kind of misconception which is going on in the industry right now. Right? These training partners, these technologies would come to you and say Spark is real time. No, Spark is not real time. Spark is batch oriented, faster batch oriented. Right. So quickly, I wouldn't spend more time on this. I wish I had more time here. I have the energy to speak for another 4 hours, but alas, the time is so less. Priyanka is saying, is Spark a part of Hadoop? No, Priyanka, Spark is not a part of Hadoop. Spark is a completely different. So hold on, Priyanka. Let me just explain the entire Spark to you, and then then you'll get an idea. All right. Patrick is saying, would you like to be kind? Would you be kind to share your email ID? Patrick, you can get in touch with the support team in Simplilearn. But bounded by the contract, I'm not supposed to share my personal information with the participants. But Simplilearn would more than happy to to answer you. To provide this to you, right? So Ravindra and all these guys, we're talking about advantage of Spark over MapReduce and all. Give me just 5-10 minutes time. Let me explain what Spark is. Let me explain what MapReduce library, Mlib library of Spark is, and then I would be happy to take questions. I think a great amount of questions would already be answered for you, right? When I'm done with the presentation. Okay, Ravindra, Shobit. Right. So these questions, if you can just, I'll spend some 15 minutes on the questions. Don't worry. Okay, quickly. The time is less, so I have to move on. So Spark is a fast and general purpose cluster computing platform. It provides high-level APIs in Java, Scala, Python, and R. Right. It provides 3 kind of shells. I'm going to show you one shell just now. Right, and an optimized engine that supports journal execution graphs. Right, there's something called as DAG, direct acyclic graph, which it makes in the RAM. Spark makes in the RAM. It never writes on the hard disk unless until the final output is really required to be written. right? Unlike MapReduce, where every mapper writes on the disk on which the mapper is running, right? So it is a general execution cluster platform, faster, more performance efficient. It also supports a rich set of high-level tools, right? So the basic core of Spark is there, and then there are high-level APIs as well. Spark SQL, which is more of SQL-ish like, right? Mlib, machine learning, graphics for graph-based processing and streaming, right? Let me, at this point of time, my friends, show you one graphic so that you get an idea about what it is. Right? This is what is Spark, right? You've got Spark over here, which is Spark core, which runs on certain schedulers, like standalone scheduler, which comes along with Spark. It also runs on Yarn, and it also runs on Mesos. These basically are called as cluster managers. Right? These basically are called as cluster managers. Right? As I said, RK, right? You know, if you can keep your questions, noted down. Later on, I will, have ample time to answer your questions, right? So just note down your question, right? Because it's there's very less time. I have to complete a lot of portion, and no matter how much time it is, I am going to pick up the questions and answer your queries, and then only we'll end the session. Right. So quickly, I'll just complete a few important things, and then I'll pick up your questions. Right. Again, Mustafa, I think maybe I'm not clear enough. Again, you are asking questions, so So okay. So what I'm going to do is that I'm just going to ignore. Please don't mind, and for the time being, carry on with the content for the benefit of all the other participants, and then I'm going to pick up these questions. Okay. So this is what it is: Spark SQL, right? Spark streaming, Mlib, graph-based processing, right? Graph-based processing and things like that, right? Spark core. So this is what Spark is: the core API, and then some higher level of abstractions like Mlib, like GraphX, like Spark streaming, like Spark SQL, right? And then you've got these schedulers like Yarn, Mesos, and all. In fact, if I am able to come out of here, I'll tell you. Let me just come back here and tell you this: the Spark definition, Spark definition and graphical representation I just not showed you. Right. I'll quickly take you to one of the posts on my blog, which is going to be very, very handy for you in order to understand Spark a little better. And as you can see here, I have done this post which says similarities and difference between Hadoop and Spark architectures, right? So here you can see that just like Hadoop has got something called as driver, Spark has something called as a Spark context. All right, so that's what I was saying, that this is one of the posts on 9th June which I have made, which says similarities and differences between Hadoop and Spark architectures, right? So here you can see that just like Hadoop has got driver program, Spark has got something called as a Spark context. Just like Hadoop has got, as I was saying, slave node, Spark has got something called as worker nodes. Hadoop has got something called as mapper and reducer, Spark has got something called as executor, right? Right. So you can see these similarities and differences between Hadoop and Spark with this post. I suggest that you guys. I was actually making one proposal for one of my clients when I thought of documenting this. So you can go through it and have a look at it. Right. It'll give you an amazing idea about what is the similarities and the differences between Spark. At which time I think it will be pertinent for me to show you this graphic. Right. You can have a look at this. Right. See, there's a driver program where you've got Spark context, right? You've got cluster manager which you can choose of your own. You can have Yarn cluster manager which would let you use Hadoop, right? You can have a Mesos cluster manager which is a cluster manager of its own. You can have a Spark's own cluster manager called a Spark scheduler. Basically, as you can see, this cluster manager acts as a conduit between Spark context and your underlying cluster. right? You write your business logic over here, right? Through cluster manager, it goes to the executor, gets run, and then you get the result back at the Spark context, right? This is what it is. This is how it works, right? And one of the basic abstractions, right? One of the basic abstractions in Spark is something called as RDD, right? Resilient distributed database data structures, right? Resilient distributed data structures, right? So what happens is when you create RDDs, right? I don't have much time to get into the details of it, but let's just give you a brief idea about it. When you create RDDs, what happens is that, and when you submit them, what happens is that your data goes and gets and sits on these worker nodes. Sparks make sure that when you create RDDs, your data goes and sits on these executor nodes. And when you run actions on it, saved on they get saved on the worker nodes, right? And they get processed by the executor, right? They get saved on the worker nodes and they get processed by the executors. Executor is something which gets initialized by the Spark framework itself. Okay, so you guys are back with me now. Did you guys get the definition of RDD, or should I go ahead and repeat it? Go ahead and repeat it. Let me go ahead and repeat it. Sure. Right. So an RDD in Spark is simply an immutable distributed collection of objects. You load data in RDD, and when your job runs, this data gets distributed across your worker nodes. Right. As you say, each RDD is split into multiple partitions when your job gets run. Right. So if you go to this graphic, right, if you go to this graphic and see this, what you can see is that from the Spark context, when you submit your job via cluster manager, the data goes to the executor node and these tasks process them. Right, these tasks process them. Right, so yeah, I'm repeating it. Yeah, these tasks process them. So that is what is RDD is. Again, quite a detailed concept which needs, at least, maybe an hour or two to, get into detail. But this is what it is, right? There could be multiple type of RDDs. There's something called as transformation, in using which you either load data, right, or create another RDD, right? So that is what is. Like filter, for example, is a transformation, right? And then there are the following two types. There are following two types of RDD. I should say the following two types of RDD operations. Transformations construct a new RDD from the previous one. Filter, for example, first line, last line. Those are the transformations. Right? Actions. Action on the other hand compute a result based on RDD. They are more of result oriented. Right? When you say action, you can relate to it to this graphic. You can, when you say transformation over here, right, the data goes and gets sit over these worker nodes. But when you say action, the actual task is run and the result is sent back to you at the driver level. So transformation lets you deal with the data and save it on these worker nodes. Action let you start these tasks and give you the result. is the definition of RDD, quickly done over here, right? And this is quickly the two types of RDD, transformation and action, right? Now, with this background, okay, there are a lot of people who are saying there is an audio problem. Are you guys facing any audio issues?
No, Syed, your voice is audible. I don't
Hello?
see any. Syed, this is Mohammed here from Simplilearn Operations. I don't find any audio issues. Everything is going smooth because I'm monitoring the session.
Yeah, I don't know why almost everyone after every 10 minutes is complaining that there is an audio issue.
Okay, but I did not find any issues. So let me continue, Syed. If something I find that the voice is getting break or the audio is not there, I will definitely ping you on the chat, or I will unmute myself and I will.
Yeah, I don't know. See, Rajneesh is saying your voice goes off and on in between. Pagoda Lakshmi is saying your voice is not, it will be good if webinar could have been recorded. Webinar is already recorded. That's not a problem. It looks like folks are guessing there are audio issues. It was breaking. I don't know. Anyway, so I'll just continue. I think that is the best policy because I think majority of it I'm already done with.
You can proceed, Syed. If there is any disturbance, I will get in touch with you.
This is Mohammed, right?
Yeah, Syed.
Okay, I'll proceed. Okay, thank
Okay,
you.
thank you.
All right. So guys, I'll just proceed. Right. Yes, the recording will be, details will be given to you, Patrick. So all of you all, the recording will be provided to you. So that's not a problem. Okay, and since the support team is saying that they are able to hear the audio fine, that means the recording would also come fine. That should not be a problem. Okay, guys. So I'll just continue. I'll just quickly tell you what machine learning is, right? And basically different type of machine learning, algorithms, right? So which is the quick topic over here. Machine learning is a method of teaching computers to make and improve predictions or behavior based on some data, right? Quick example, you would have seen in your Gmail account, it automatically on its own learns, right, which mail to send to your main tab, to main label, which mail to send to your promotions and social labels, right? It knows how to categorize and which one to send to your spam, right? That is behind the scene machine learning working for you, right? So it's a method of teaching computers to make and improve predictions of behavior and take decisions on the basis of some data. And this is something which can improve over a period of time, right? You provide some data, it does some improvement, then some more data, some more improvement. Over a period of time, it keeps on getting improved, right? The data depends entirely on the problem. It could be reading from robot sensors and it learn to walk, or correct output of program or certain. The data could be anything, right? You make a robot, get the sensing data from the robot, from the sensors, and slowly start teaching it to walk, right? It could be something like that. So it's basically teaching computers to make and improve predictions or behaviors, right? So it's a method of, let me just highlight this, teaching computers to make and improve predictions and behaviors on the basis of some data. That is what is machine learning. Now, guys, machine learning can be of two types: supervised machine learning and unsupervised machine learning, right? Supervised algorithm use labeled data in which both input and output are provided to the algorithm. Example, email spam detection. That is supervised machine learning. You know the input, you know the output. You know that if there are certain things which are repeating in your email, right, send it to promotion or send it to social. But if the text look clean, send it to your main inbox. Right? One of such technique in machine learning is known as classification. Right? Unsupervised machine learning. Unsupervised algorithms do not have the outputs in advance. These algorithms are left to make sense of data without labels. Right? An example is Google News. No labels over there. Right? No labels over there. Right? You just put the algorithm and it accordingly on its own starts doing the grouping. This is top news. This is sports news. This is technical news. This is Bangalore news. This is US news. This is Australia news. Right? One of the techniques which help you do that, which Google News actually use, is called as clustering. It's actually clustering. Right? It's actually clustering. Right? Forecasting is basically a third kind of technique called as collaborative filtering. Prithvi. Right? If time permits, I'm going to show you some links to understand that classification. Right? Now, machine learning steps and methodology. All right, steps and methodology. Using Spark, let me say using Spark. Then it will be better. It should make sense. Okay? Right? Create RDD from your input data. Let's say I want to do spam detection. Right? I'll provide normal data, I'll provide spam data. That is the first thing that you will do. Right? Create RDDs of your input data. Run one of your Mlib feature extraction algorithm. Right? Now you want to find out whether your mail is spam or normal. So the second step in this exercise is to do feature extraction. And for that you use some kind of feature extraction algorithm. Right? Feature extraction algorithm would, for example, in Spark Mlib library, there are some feature extraction example called as hashing TF. What they do is that they try to find out the hash, the ASCII value of each and every word. They try to divide the content of your mail into word, right? Into each words, and then they try to find out the ASCII value of it. And then this hashing algorithm basically takes a value. It does a modulo function on that. Right? So if you have worked in Spark, if you worked in Hadoop, you would know something called as default hash modulo partitioner, which works when you make reducers in your job more than one rather. The moment you make your reducers more than one, a default hash modulo partitioner starts working. Right? And it does a modulo function on the ASCII value of the unique key. And on the basis of the remainder, the modulo quotient, it lets you decide which key to go where. Right? It lets you decide which key to go where. Right? So hashing algorithm is in Spark machine learning library is one of such algorithm which does hashing of all your words. And it starts mapping it to numbers. So if you have given, for example, a hashing algorithm with a number 10,000 or 1,000, it starts giving numbers to your word from 1 to 10,000. Right? And start creating the category. Right? And then you create label. That is the third thing that you do. So basically over here, the second thing is feature extraction algorithm. Right. So you use some feature extraction algorithm to basically convert your word and map them, convert your words into numerical value and map them to some numbers. Right. And then you create labels. For example, this mail is spam, this mail is non-spam. Right. This mail is my mail inbox mail. This mail is my promotion social mail. This mail is my promotions mail, and you can create labels of your own. Right. So you create label as a third step. Right. And then you create something called as label point data set. Now this label point data set is where your labels start interacting with the output of feature extraction. Right. These feature extraction give you an output in the form of vector. Right. So this label point point data sets, map these labels to those vectors. Right? Flight delays or non-delays, spam or non-spam, and they associate it with corresponding vectors. Right? They associated with corresponding vectors. Right? Once you have this data, right? You have the spam data, you have the normal data. Once you have this data, you create training data. I have some spam data with me. I have some normal data with me. I will create a training data. Right? Now the training data is created. Right? Once the training data is created, you run through that training data using some kind of classification algorithm. Right? These algorithms are provided to you by the library. Right? These algorithms are provided to you by the library, by the machine learning library of Spark. Right? You create a model. You create a model and then you test that model. You test that model, use test data set and keep on improving the model on the basis of the test data set. So it's a feature of these 6 steps. Right? What I'm going to do now is I'm going to quickly show you this feature in terms of some graphical representation and then run the example for you. Right? Then run the example for you. There you go. Right? Featureization. Featureization, feature or feature extraction, day of the week, scheduled departure, original airport, career. You start featureizing your normal text into numerical values. Right? Whatever normal text you have available, you do a feature extraction of it. Then you create training data by combining them. Then you create a model and start evaluating it. Right? And then you start testing that model to get the result. Right? Right? So this is, so you would say, by this looking at this graphical representation, you would say that the entire thing is divided into some 3 or 4 parts. Feature extraction, where you do your text mapping to the numericals, to the numerical value, training the data by combining all the feature extraction that you have had, creating a model, right, and testing a model. Right, creating a model and then testing a model. I'll quickly come out of here since we have less time now. I'll quickly come out of here and try and run an example for you. I actually have a spam classifier example which I have written in Scala, right, which I can show you on a Spark shell. So let me quickly come over here. Yes, Rohit, you can just mark your question. As I've said, you can just keep your question in in your notes. I'll spend some 10-15 minutes time at the end of the session to run the questions for everyone. Okay, so as I said, I'll just clear this. Give me a moment. Just give me a moment. Yep, there you are. Right, I have Spark integrated with Hadoop 2.x already installed on my machine. Right, so I'm just starting a Spark shell in Scala for it. Okay, so let the shell start. So Rohit Londe, as I said, you can keep your questions marked with you. I will not be in a position to read it right now. Later on when we'll come to a query question answer session, that is the time you can post it again. Right, so you can come here and you can see things like these. Let me show you a couple of examples. So something like, let me see what I can show you. I can show you something like this. I have this data called as test.txt on my HDFS. So I'll say Hadoop fs-ls slash Hadoop data slash word count. Right. So see, I have test.txt. I can say test.txt. I can do a cat of it over here in Hadoop. I can load the same data in my RDD in Scala, in Spark. Scala shell for Spark. Okay, so data is now, in fact, let me call it Control A, let me call it test. Right, and on test, I can do things like, so when I loaded this data, this basically created an RDD, right, which can go and work on one worker node, because this is a single node installation of Spark, right. What I can do is that I can run certain functions on this. This gave me the first line. This gave me the last line. No, actually last is not there. You can do a count. There's 7 lines in it. Right. So you can do all this. So when you're doing first count, these are all actions. When you loaded the data, this was transformation. Okay. Excellent. Very good. So what we're going to do is that we are going to quickly run that program with those 6 or 7 machine learning steps. Right. What I'm going to do is that, and I have this file again with me. You can have this file from the support team if you want to run these programs for a Scala shell for your own self. Right. So I'll import all these packages over here. Right. See, this is my hashing algorithm. This is my regression logistic algorithm. These are Mlib APIs. Okay, I've added it over here. I could have very easily done this in my Scala studio also, but anyways, I am doing it over here so that you get an idea about. Right. So Control L, just run this. Right. What I'm doing is I am loading a file called as spam.txt. Okay, let me just show it to you first. What is a spam.txt on HDFS? It has some spammy data. Dear sir, I am a prince in the far kingdom you have not heard of. I want to send you money via transformer. Right, get Viagra, real cheap. Oh my gosh, you can really be strong too with these drugs. Your computer has been infected, and these kind of, we know what these messages are, right? Right. This is not a scam, whereas in fact, indeed, it is a scam, right? Right. So, anyways, this is my spam file, which I'll load as an RDD. Right. In the spam file, also, I can run my spam.actions. Yeah. Right. These kind of things. Right. At the same time, I'm also going to run my normal file. Right. Here also, my normal file I'm just taking as test.txt. Right. And then I'm going to create a hashing algorithm, an instance of hashing algorithm. What this is going to do is that it is going to say that create a hashing algorithm where the value to create the modulo is 10,000. Create the ASCII value of each and every one in these files, each and every words in these files, spam and normal. Create an ASCII value, do a modulo by 10,000. Whatever value you are getting, start hashing it. Get a numerical value for it, right? Start aligning it so that we can do the categorization. Right? So basically it is doing the categorization. It is helping you to do the categorization of your data. Right? So I have declared and this is well documented. This file is very well documented actually. Right? So this is what it is. Now see this. Each email is split into word. Now, right? And each word is mapped to one of the feature using hash modulo done by s is equal to 10,000. Each of the word of the spam and the map file is mapped to one value by doing a hash modulo. Right. So here we will get an RDD of vectors between 1 and s minus 1 because hash modulo can be from 1 to s minus 1 because s is the divisor. Simple 10th mathematics. This is done for both normal and spam files. Right. So we'll do first for spam. This is basically what we're doing is featureization. Right. And then we'll do for the normal files. Right. And then we'll create label points. Right. Positive examples, negative examples. Right. It's the positive examples. We'll take spam features. We'll say if it's a spam, call it positive. Negative examples is normal, not a spam, normal proper email. Good. Labeled points are created. Right. So I've created a hashing algorithm. I have mapped my text inside my email to this hashing algorithm, and then using label points. See, these are steps. Right. Featureization, create labels and their label point data. Label point data is usually label associated with their corresponding vector values. Vector values is something which is received from here. So you receive the vector value in terms of the mapping of your individual words, which you have it here, and then you map it to the labels. Labels is spam or not spam. Right. So you're doing the labeling. Right. You're doing the third step over here. So come back here. I've done the labeling. Now I'll create the training data. I have the label data along with the categorization from the hashing algorithm. I'm creating the label data right now. Right. I'll create the label data right now. Right. Variable is equal to label data. Excellent. The training data is available to you. Now you create go back to these steps. You've created the label data, you've created the training data, now you create the model using some classification algorithm. So classification algorithm and feature extraction algorithm is something which is provided by the Spark Mlib library for you. If somebody had that question, I think. Right. It is provided by the feature extraction algorithm. So amazing. Very good. You come back here and create the model. Let's create the model. Let's go ahead and create the model. Spam classifier. Right. Using the training data. So I come back here and using the training data, I have created the model. Now it is creating the model for you. Right. It says numerical feature 10,000 because my hashing algorithm has 10,000 features. Numerical classes too, spam and not spam. Right. And that's it. Now you can test your model. That is the next thing that you do. Right. In the steps. So you say, okay, for positive example, let me do the test. Right. And for negative example, let me do the test. Let me do it again for you, guys. Yeah. So it gave you that vector. Saying that which is the one which is positive. So it is positive, it is going to show you 1.0. Right. And for negative also, it is going to show you 1.0. Right. And these are the vector values that it has given. Right. Excellent. Now you can see your prediction. Prediction for positive test sample. So I have given a spam value. Right. And I'm checking whether my model is really telling me it's a spam or not. If it is a spam, it is going to give me a value of 1.0. Let me go ahead and check it. See, give me a value of 1.0. If it is not a spam, it should give me this value of 1.0. Yes. If it is not a spam, it will give me a value of 1.0. That means we started with spammy file and non-spammy file. Map that with feature extraction so that it converted each and every word of that file into numbers, right, representing them spam. And then I created label data where I associated label of spam or non-spam with these vectors. Then I created training data by combining these two data sets. Then I created a model. Then I tested that model. Right? So feature extraction, obtaining vectors, right? Labeling the data, combining label and vectors coming out of feature extraction, creating the training data, creating the model, testing the model. Right. In fact, let me just, why not go ahead and, like I do in all my sessions, write it down for you in summary. Loading the data in RDD, feature extraction or featureization, labeling the data, associating labels with vectors obtained in feature extraction, creating the training data, then creating the model data, creating the model, testing the model. Actually, I should say providing the sample. The samples and testing the model and making predictions. This is pretty much what it is. Right. Since we had very less time, I'm not able to get into more details of it. If you guys really want to get into more details of it, you can join one of our sessions on Spark, Big Data, Hadoop, and all, and we can give you provide you more detail, more intensive this about it. Okay, so as far as the portion of this presentation is concerned, I think I'm pretty much done on it. Now you guys can go ahead and can ask your questions, guys. I'll be more than happy to answer all your questions now. Is Java mandatory for MapReduce? Java is mandatory for MapReduce and Hadoop, yes. Right. Suresh is saying creating REST-based inference service using machine learning. Give me 1 second. Huh? I'll just stretch this a bit so that I can read your question. Creating REST-based service inference service using machine learning model. 1 second. One second. Huh? I'm just trying to read your question. Okay. The webinar was awesome. Thank you. What about unstructured data or clustering? What do you know about unstructured data or clustering? You can work on unstructured. So unstructured data. So basically, here what I was dealing with a very specific topic, Shraddha, of doing machine learning using Spark API. And give you some background of Spark, some background of Hadoop. Unstructured data for doing business analytics is a separate topic, which I deal with in either my big data course or my Spark course, which you can join and get more details about. Mustafa is saying, Rizvi sir, what is the basic difference between classification and clustering? Mustafa, both of them are a type of machine learning. Classification is supervised, where you have output and input both available. Like as I said, I give an example. Gmail, your mails is an example of classification. Of the spam classifier that I was running for you was an example of classification. Clustering is unsupervised, right? Example is Google News, right? Where you have the input and you let the output, you know, collect on its own. So that is the difference. Shivanshu is saying, how come Spark does not need a dump like MapReduce? Spark does need a dump like MapReduce, and that's what I have done in RDD, Shivanshu. Over here, when I was running this example for you, this basically was a dump from HDFS. Right, so this is where Spark is talking to HDFS. Shivanshu, negative test should have 0, right? Ravindra, negative test is given 1 because I am providing the normal file to the negative test. Okay, if I would have provided a spam file to the negative test, it would have given me 0. Ravindra. Can the distribution of data in RDD is configurable? No. RDD is something which is decided by the Spark runtime, by the Spark framework for you. So you cannot, it's not in your hands to decide which data will go where. Just like in HDFS, it's not in your hand which block will go to which machine. Right? Sam is saying, could Python be used? Yes. So Spark give you APIs in 3 languages, as I said: Spark, Scala, Python, and Java. Martin is saying, but you should use Pig or Hive also. I'm not sure in what context you are saying that, but again, Pig and Hive over MapReduce is slower. Pig and Hive over Tej or Spark can be faster. So as I said in the initial beginning of my session, that Pig and Hive, you know, as is going to give you warning if you start using it these days. It says start using MapReduce, start using Spark or Tej. Martin. Sam is saying, how does Scala play a role in this? If it does play a role. Sam, Scala is basically the language in Spark is written, first of all. So that's one of the biggest role of Scala. Secondly, Scala, you can write Spark programs in Scala, as I just ran one program and showed to you. Right. So, and as you might know, but let me just tell you, Scala basically is an improved version of Java. All the fallacities, all the issues that you have ever had with Java, something that is overcome by Scala. So that is another reason why you would, you know, use the Scala over here. Ketan is saying, is Scala recommended language for writing Spark RDD? How can we use R on Spark? Scala is not, basically the API is given so well for all 4 technologies: Python, Spark, Scala, and Python, Spark, Scala, as well as for R, that you can use any one of them equally well. Ketan. Difference between Flink and Spark. Suhas, I'm not sure if I've heard about Flink, to be honest, so I cannot comment on that, I'm afraid. How can we do translation by machine learning in Spark? You'll have script, just like, you know, you have to go through these go through these steps that I've told, right? If you join my session, we can take this as an example, and we can, you know, go ahead and implement this. Patrick is saying, thank you, very good learning for me, good night. Tanmay is saying, so we can conclude that we have to install Spark over Hadoop, but the question is no. So you can install Spark over Hadoop, or you can have you know, there are various ways in loading data, for loading data in Hadoop, in Spark. It not necessarily you need Hadoop for it, right? You can load data directly in Spark using its own cluster manager. So Hadoop installation is not a prerequisite, or HDFS installation is not a prerequisite for it. Right. The time was less, so I could not show you all the scenarios, Tanmay. But no, HDFS is not a prerequisite. Difference between Splink and Spark, I told you. Fraud detection can be clustering. Yes, fraud detection is basically, yes, I would say clustering. Yes, Prithvi. For machine learning language, it is like we need Scala. No, Tanmay, it's not like that. Just one second, Tanmay. Machine learning no, nothing like that. You can write machine learning program in any one of these. Right. Somebody saying which is Simplilearn course is geared towards Spark machine learning, or is it a general course? So Simplilearn has got a course in Spark, specifically in Spark actually. If you go over here in the courses section, you can see a specific course in Spark over here. All courses, data analytics, Apache, Spark, and Scala. Right. Does Simplilearn have a course in Hadoop admin? Yes, I would suggest you go to simplilearn.com. Big data analytics. There will be a course in Hadoop admin over here. Big data analytics. Big data and Hadoop administrator. Okay, which Simplilearn course is geared towards Spark? Kindly share the recordings and docs. Surely, we'll do that. What's the market stand in market for jobs in Spark and Hadoop? Pretty much the market is pretty hot, Tanmaya, at this point of time. In fact, the job market for Hadoop is very hot, and job market for Spark is even super hot because this technology which is recently, just in 1 year, has come into the picture. So yes, there's very less skill level available. You can go ahead and learn Spark and you know do well in the industry, Tanmaya. Okay. All right, guys. Any other questions? Which course do you teach? I don't know what his name is, but I teach Big Data and Hadoop. I teach Spark and Scala. I teach MongoDB. As I said, I think you missed my introduction. You know, I teach almost all the technologies. Which courses do you teach? Is there any scenario where map reduces more? So this is a question for a full-time session, not over here. Thank you, Syed. Have a good evening. Thank you so much. Thank you so much. To get a job in Spark, is Hadoop background required? Not really, but it is nice to have. Is there any recent batch coming up of yours in Hadoop? Yes, there's a batch starting from 20th August, morning 9 a.m. IST to 1 p.m. IST, Tanmay. You can come and join. Martin saying thank you. Great presentation. Oh, Anthony, my old friend. Thank you so much. Thank you so much. Thank you. All right. Thank you so much, guys. Thank you so much, guys, for joining. Thank you so much for listening to me. Unfortunately, the time was very less. As usual, I had content to speak for a longer period of time. But nevertheless, I think you got some takeaways, and yep. Look forward to see you soon in one of my classes. Thank you so much for joining, guys. Thank you so much. Bye-bye. Take care and have a good night, have a good day, and God bless to all of you all.